Welcome back. I'm René. I work for Bridge Diagnostic in Boulder, Colorado. In this session, we're going to actually use STS-MONITOR to collect decimated data from the incoming data streams of our sensors. Let me show you how you do that. First of all, make sure that you are in monitoring mode. Then we go to this page, which is blank. There is no test specified. Go into the editor, and we're going to tell the system what kind of tests we want to run. So we will do decimation, but because we want to check if it really works, we also will do normal recording. You see now that we have two tests defined: define decimation and define normal recording. If you want to delete one of these tests, you go into this function. Let's say that we don't want to do a normal recording and it is deleted. It will delete with all its content, so it's quite handy if you have a long specification to use that function. But in this case, we want to do normal recording and we want to do decimation. Go into the editor, and now for the type of test recording, we can specify multiple groups. So we do demo normal. And we have now a group called demo normal, but we can also make demo 2 normal. If we send this test specification to the core, that would mean that for normal recording, we have two tests running, one called demo 2 normal and one called demo normal. That can be very handy, for instance, if you do event recording, or if you do decimation, but you want to do decimation with different decimation parameters on different sensors. For now, we don't want that, so we can delete that group. We will add a group under decimation, demo deci, and we have specified our test groups. Under normal recording, if you double click on the name, you immediately are moved to the page to select your sensors. Let's select these 3 strain gauges. I can do that by using Ctrl-Shift and move them to the sensors in the group. I can also move all the sensors in the group back to the available sensor list. Or I can move by Ctrl-Shift or by double clicking. If I double click on the sensor, it moves to the sensors in the group, and vice versa. We are done here, and we can see now under normal recording that we have 3 sensors selected, but there are no parameters needed for these sensors. We do a recording without any signal processing. Double click on demo, and we have a specification field for the parameters needed for decimation. There are basically only 2 parameters. The first one is the sample rate, the reduced sample rate. And the second one is an out of range alarm repeat. I will come back in a later session on how this functions. Let's say that for now we want to sample with 1 second, which is the lowest of the highest sample rate we have in decimation. Decimation normally runs at 1 sample per 1 hour, whatever your needs are. So let's add sensors. And you see that this is a familiar interface now. So we're going to add 3 strain gauges, and we are done here. Let's see what we have. We have now 3 sensors specified, and they have automatically a parameter for average. If we don't want that, we can double click on the sensor and tell the system to add other parameters of that signal. We can run max, min, RMS. These 2 values, excitation and temperature, are available on the sensor, but it depends on the type of sensor. If you have a strain gauge, excitation would give us the excitation voltage of the strain gauge. This is good for monitoring if your signal conditioning is properly set up. In this case, we use amplified strain gauges which have onboard excitation and it cannot be monitored. So I have to remove this here. And I don't have temperature sensors in my strain gauges. So this is correct now. And we see that the difference is now for this number 4 sensor, we have average, max, min, and RMS. The other sensors are only average. We can get out of this editor and we go back to the first page. The first page, now you see what we specified. This specification can be saved to file. Let's do that. I already have a demo deci, so let's overwrite that. So you can now retrieve also that information. Let's delete this block of text and open that file location. It's on a odd place, and here it is back. It is the type of the file is CSV, comma separated. Any Excel spreadsheet program can open this file, and you can edit all these settings in an Excel spreadsheet. If you have a large sensor count, that is very convenient to do. But please start by using this editor so that the syntax is correct. If the syntax is correct, you can copy and paste large amounts of parameters to your sensors. We are finished with this first test specification. Oops, let me go back. We go back to the settings. And now in our monitoring page, we see the specification of the test. When you leave the editor, the specification is automatically sent to the core. So when I start now a test, the core knows what to do. We started, and let's look at our sensors. And here you see that we have now new sensors defined. We have a demo deci, and I have to manually activate these sensors, telling the core that I want to see that data. And we have normal data from the sensors. That is a big difference between STS Live and monitoring. In monitoring, you have to tell the system that you want these sensors to be displayed. Please remember that most of the time you will be talking to a remote site where the core runs, and all this information has to be transferred over a TCP/IP connection. If that is a modem, then the data rate of that modem is very low and you cannot maintain all these sensors. If you have a large sensor count, it would clog up the whole channel. So we do not automatically enable these sensors for data retrieval. You have to do it manually. Let's make a signal. And now we can look at how that the normal data and the decimated data looked. We can stop the test. And let's turn off the normal data. And we see that the decimated data is only a few points. We can zoom in to that event. And you see the whole vibration is now reduced basically to 3 points. Let's look what the system stored. Let's open that up. 3-dimensional columns. Okay, I skipped to finding the proper folder. It is always on the same place. It shouldn't be much of a surprise what we are seeing here. And we see that we have two. Do that back. Additional. You see that we have the normal over the mean recording, and we have a large file size is already 240 kilobytes, which is quite large. The decimated data is only 8 kilobytes, and that is mainly because of the metadata. We had only a very short test. The structure of the file name is the same as STS Live. It is the project name followed by the date code. But in this case, we also add to the file name the group name of our test. So decimate demo deci. and we know that this is the decimated test. Let's open that. Go to demo deci, and here you see that now we have a timestamp of 1 second, and we do have an average signal from the 3 sensors, but we also have the max, the minimum, and the RMS value of sensor number 4. So I'm going to look at these 4 inserts. And we can see here the minimum and the maximum of the data. Thank you for your attention. In the following session, we will make a test for event recording.